Think of how we graph this linear inequality in two variables. We begin by looking at the corresponding equation. In this case, 2x minus y is equal to 5. And that's how we find the boundary line. So let's graph this equation, and we'll do so by finding ordered pair solutions. Why don't we find the intercepts, and that should help us. To find the y-intercept, let x be 0. If x is 0, I would be solving negative y is equal to 5, so that would mean y is negative 5. Let's find the x-intercept by letting y be 0. If y is 0, we're solving 2x is equal to 5, and divide both sides by 2, and x is 5 over 2, or 2 and 1/2. And we'll use the intercepts to help us find this line. So 0, negative 5, negative 1, 2, 3, 4, 5. There's my y-intercept. 2.5 to the right, 0 up or down. That's my x-intercept. I'll let you find one more ordered pair just to make sure they all three lie on the same line, but they will in this case. And now I'll draw my boundary line, and I will draw it dashed because the boundary line is not a part of the solution region of the original inequality. The inequality sign, strictly greater than or strictly less than, remember we draw a dashed boundary line. By the way, that is the only need we have of this corresponding equation, and that is to find the boundary line. Now, I need to shade one side of this equation. Now I need to shade one side of the boundary line or the other. How do we decide what side to shade? We find a test point not on the boundary line, and we check the test point. I'm going to check the point with coordinates 0, 0. So I'll let x be 0 and y be 0. If x is 0 and y is 0, I have this inequality, which is either true or false. 0 is greater than 5. That is a false inequality, which means I do not shade the side of the boundary line where the test point lies. I shade the other side of the boundary line. And I am shading then all ordered pairs that will make this a true inequality.